Hi everyone, in this video, I'll walk you through what is regular expression and how to use it in programming. The purpose of regular expression is used to search for text information by matching specific format that can be found in a string. Now, the string can be contained in a text file, a CSV file, or any other format files. Now, some examples of text that contains specific formats include dates. So if you want to search for a date in a document or in a text file, the dates generally contain a specific format. For example, you can start with day, and the day would be perhaps written in the format of 2 digits, followed by a hyphen, followed by the month that contains 2 digits as well, followed by another hyphen and 4 digits of the year. Or alternatively, it could be written in this style as well, where the month is written in letters, okay, instead of digits. Now, email address is also has certain format. For example, the format usually starts with a set of characters. Usually, it is the user's name, and the user's name may include symbols as well, like for example, a hyphen, all right, to separate the first name and last name, followed by the @ followed by the email provider and a .com. So we can specify in regular expression that we want to search for a set of characters with a @ ended with a .com, and with that we can use it to search for that format in a string, and if it is found, it can be returned to us. Okay, so passports and phone numbers also contain specific format as well. So in the context of Singapore, the phone number, or rather the mobile phone number, will contain 8 digits. So we can specify in regular expression that we want to search for text that contains 8 digits. All right. So the regular expression format is written to match the text format in a string. Now, the search of the format is then carried out by search functions in Python. Now, when there is a match of the format in any part of the string, then it will return the value or location of the match format. All right. Now, you will learn two of these search functions in Python using the RE module. Okay, so to use the function, you will first call for, you import RE, and then basically you just specify RE dot, right, and use the search function. I will walk you through how to use them. The next function that you will learn is find all. So these are the two basic search functions that we will learn from the RE module in Python. Then we will learn to construct basic regular expression to match text that contains uppercase and digits format in the string. All right, now we do so using character set that denotes by a pair of square bracket. All right, it looks like a list, but it is not a list. All right, it is in the context of regular expression, putting 2 square brackets would mean that this is a character set. Then we will learn how to use quantifiers. There are 3 quantifiers that you will learn, the dot, the @ and the asterisk quantifier. All right, so with that, let us get going. Remember to create a new Python file so that you can follow along to learn regular expression with this video. Now, to use the function of searched and find all, you will need to import a module called RE. All right, so go ahead and import the RE module. And I've also gone ahead to create a string and assign it to a variable called target string. So let me just execute the code to show you the string. So the string contains 4 lines, and they're all printed in separate lines because I've used a \n at the end of each sentence. So when I scroll through the right, you can see that each sentence would have a \n. So it will begin in a new line as I print in line 25. Okay. Now the string contains the name of the fruits, right? So the first line contains pineapple. It is more like an item of pineapple. So the pineapple is in uppercase, and ice cream, so it is a pineapple ice cream. And pineapple is in uppercase and it has a value of $20. The second item is also in uppercase, and this time around it is really just the name of the fruits at $10, followed by apple, uppercase at $5, and orange, uppercase at $4, right? So we will learn to use regular expression to extract this pattern of uppercase so that we can extract the name of the fruits, followed by extracting the digits, all right, since the value of the fruits is in a digit format. All right, so let's get going, and first let us learn how to use the search and find all function. Let's look at the search function first, and to use the search function, let's move to the next slide and simply call for the module re.searched, followed by parenthesis. Now the search function will contain two parameters that we need to supply. First would be the pattern parameter, followed by the string parameter. Now the pattern parameter is simply the specific format that we would like the search function to search for, and the string is simply the string that we like the search function to search through. So in this case, our string parameter will contain the target string variable. Now let's see an example of a simple pattern. So let's call for the pattern parameter, and let's search for a simple pattern of just an uppercase pineapple. So we supply this pattern parameter with the apple, pineapple in uppercase, followed by the string parameter, and simply supply it with target string. So the search function will search for the pattern of uppercase pineapple in the string of target string variable. All right, so let's just print the output from this search function and let's execute the code. So from the output, we can see that line 25 would still be printed. So we will still see the output of our string, followed by the last output, which is the output from the search function. Now, since there is a match, because uppercase pineapple is exactly what we specified as a format, we can be quite certain that there is a match, and the output indeed returns a match. Now, when there is a match, the search function will return a match object. All right, and there are two informations that it provides in this match object. First is the position of the match object. So span equals to 15 to 24 refers to the position in the string of this match object. So 15 to 24, from line 24, you can see that it belongs to pineapple. And at the same time, it also returns the second information called match equal to, and this information is the value that it managed to match. All right. Now, if there is no match, there won't be a match object. All right, it will simply just return a none value. So let's take a look at an example. Let's change the pattern from uppercase pineapple to lowercase pineapple. Now, as you know, the string is case sensitive. So when you specify you want a format to be lowercase pineapple, there won't be a lowercase pineapple for the search function to match. So we can be quite sure that it will return to us nothing, or rather a value called none. So let's take a look at the output. So the output now returns a none. All right. Now let's revert back to the uppercase pineapple once again, and let's execute the code. So in regular expression, we are more interested to extract this match, this information of match equals to instead of the index position. All right, so extracting this value directly is not so easy, but there is an attribute that we can make use of from this match object. Okay, so to see an example, let me just copy line 26, and let me just copy to line 27 and assign this output or this match object to a variable. Let's call this a matched object, all right, equal to. So I'm assigning the match object to a variable called match underscore object. All right. Now, since this match object contains two information, the attribute of group will allow us to extract this pineapple value. Okay, so let me just print the group attribute to show you what I mean, and let's execute the code. So notice that in line 28, we extract the pineapple directly from the information of match equal to. All right, so in this case, extraction of the match pattern is easier than simply trying to extract the value directly from the match object, okay, without referring to its attribute. Now, if there is no match object, so let's revert back to lowercase pineapple. All right. When there is no match object, as you remember, it will return to us none. Now, none will not have this attribute of a group. So if we execute the code, you will see that it will return to us an attribute error. Okay, so when this, perhaps let me just comment out line number 26 and let's execute the code one more time. All right, so let's execute the code. So first we search for a pattern of lowercase pineapple through the target string, and it will return to us a none value, and this none value is assigned to this match object. Now, if we call for a group attribute from a none value, it will return to us a attribute error, because if you look at the output, it says that none type object has no attribute of group. Okay, so as you are writing a program to extract information that match a pattern, do not assume that it will automatically or it will always return a match, because sometimes there can be no match. So you need to create a conditions like if else, using if else statement to filter out what happened if there is no match and it returns a none, and when it returns a match, what can be used to extract the value. All right, so to see what I mean, perhaps I can show you using a if else statement. So let's move to line 30. So I can say if this search object, all right, if the search function of a lowercase pineapple, all right, through the target string is not none, all right, so if it doesn't return a none value, I would like this search function to assign it to a variable called match object. All right, so I'm going to simply just comment out line number 27, and then I'm going to print the match object dot group attribute. All right, so this is the conditions that I created, and perhaps let me just comment out line 28 as well. Okay, and then I will use the else statement and says that else simply print matched not found. Okay, so let's see what I mean. So once again, if searched function search for a lowercase pineapple through the target string is not none, means it doesn't return a none value, let's assign this search function to a variable called match object and print its attribute. Okay, otherwise else just print that match not found. Okay, so let's execute the code and see the output. All right, so as expected, we can be sure that the if statement, the body of code in if statement will not be executed, because the lowercase pineapple is not cannot be matched in the first place, and therefore the else statement of print match not found is executed. All right, now if we change this pattern to a uppercase, all right, and execute the code again, now this time around we can expect that the if statement body of code will be executed. Okay, let me just change this inner body of code pattern to uppercase as well. Okay, I forgot to change it from lowercase to uppercase, and let's just execute the code. So we can see that because there is a match this time, right, the search function would contain a match object, and this match object now is assigned to a variable called match obj, and match obj would have an attribute called group, and so it will print this attribute, and the value of pineapple is extracted as a result. Okay, so this is a way that you should think about in your code as you work on your assignment, to ensure that your program does not come to a halt because of an attribute error. Okay, so I hope this is useful. So next, let us just move to the findAll function. The findAll function is more straightforward to use than the search function. So to see an example, let's remove the conditions that we have created earlier. And also let's remove the unnecessary match object from the search function. And I'm going to uncomment out my line number 26 and simply replace searched with findAll, because findAll would also require the pattern parameter and the string parameter. But unlike the search function, findAll does not return match object. It simply just returned a list, all right, of the values it managed to find in a string. And even if there is no matches, it will return an empty list. So let's take a look at this example. So let us just replace the lowercase pineapple to the uppercase pineapple in line 26. And let me just execute the code. Now from the output, we can see that line 25 would still be printed. So the string, the 4 lines in the string would still be printed, followed by the output of findAll. Now notice that findAll returns the values in a pair of square brackets, meaning that the data type returns is a list. And it returns 2 pineapple because findAll will return all the pattern it managed to match in the string. So in our case, there are 2 pineapples in the string, so these are returned as a result. Okay, now moving back to lowercase, so if we change uppercase to lowercase and execute the code, it will return to us an empty list instead. Okay, so I think findAll is more straightforward to use than the search function, but there are different purposes of using search or findAll. You will know the difference as you progress through a regular expression, but for now, just understand how to use these two and what are the differences. Okay, now moving forward, I will just simply use findAll instead of search to demonstrate regular expression. As I was explaining how searched and findAll function worked earlier, I supplied a simple format of the word pineapple as uppercase characters in the pattern parameter, and that resulted a match of the 2 pineapples in the target string using the findAll function. Simple format like this is not good enough because it can only match the word pineapple but not the other fruits. And regular expression is really about matching a specific format instead of a word. And in general, matching by a specific format is far more useful since a format is not word dependent. To specify for a format, we can use a character set that is denoted by a pair of square brackets. Let's see a character set in action. Now I will replace pineapple in the pattern parameter with a pair of square brackets. And I'll put a group of characters. An example of a group of characters would be uppercase A to Z. This uppercase A to Z will be treated as a format to matched, and the findAll function in line 26 will match and return the characters that are uppercase in the target string. So when we execute the code, all the uppercase characters from the target string is returned as a result. But let's take a look at the results more carefully. The first T returns in the list is the first T from the first line, and then P followed by I, N, E, A, P, P, L, E, which is pineapple from the first line, and they are returned as individual uppercase character, followed by the next T from the first T in the second line, and the second pineapple written separately, and T again from the third T from the first T in the third line, and so on. Now you may be wondering, why are the characters returned as single character? Now this is because a single character set will match only a single character in the string, and that's why find all return the match as single character. Now to see it from another point, let's change A to Z in the character set to a uppercase P and I and execute the code. Now notice that this time round, the matched will match 8 P's and 2 I's from the string. So you may be thinking, why does it not match PI as an item? So why is it like PI, which is the PI from pineapple, is not matched as an item, but separately? So think about this format this way. Think about it as matching either a P or I in the character set instead of P and I. So I hope this is helpful. Now, it is also possible to use more than one character set. So we can use 2 or more character sets in a consecutive sequence. For example, let's revert back to uppercase character A to Z, and let's duplicate this character set and put it to the next. Now, a pair of A to Z in a character set will match 2 consecutive uppercase characters, but it will not match one uppercase character because the pattern that we specify is 2 consecutive uppercase character. And when we execute the code, notice that the first T from each line is not written because there is no match of 2 consecutive uppercase character. Lastly, beside a group of characters of uppercase A to Z, we can also specify other formats. For example, we can change from uppercase A to Z to lowercase a to Z. So when we execute the code in a single character set, notice that all the other lowercase characters from the string are returned as a result. Besides lowercase, we can also specify another very useful format, 0 to 9. So as we execute 0 to 9, or as we put it as a format and execute the code, only the digits from the string will be written. But since we specify only a single character set, so the digits are returned as single items in this case. Let's try one more time. Let's include one more 0 to 9. And notice that when we execute our code this time, it will return to us 2 digits. However, the single digits are not written. In the last example, the uppercase character in the target string variable are matched using a single character set with an uppercase A to Z supplied to the pattern parameter of the findAll function, and it searched through the target string variable, and then it returns a single character that matched the uppercase pattern. So when you look at the output, this is where all the uppercase characters are returned individually as single characters. We have also talked about using 2 character set in sequence like this, and this will match characters in the same sequence. So in this case, when we put 2 character set with uppercase side by side, the 2 character set will match characters in the string that contains 2 uppercase character in sequence or consecutively. Okay, so when we execute the code, you will see that the first letter in each of the line, in this case they are all uppercase T, will not be returned because it did not match 2 consecutive or 2 uppercase character in sequence. And if you look at pineapple, there is a match because PI matched the pattern of 2 consecutive uppercase character, followed by NE, followed by AP and PL. And so the last letter or the last uppercase character in pineapple, E, is also not matched because it did not fulfill this pattern of 2 consecutive uppercase character. Now, matching the names of fruits using a series of character set like this is also not helpful since the number of characters in the names varies as well. So for example, if we include more than 2 character set, we might be able to capture perhaps, let's include one more character set. So there are 5 character sets of A to Z. We might be able to capture perhaps apple, but we will not be able to capture the entire name of pineapple and orange since the number of characters that contained in the fruit name, it will be longer. So let's execute the code and check the output. So we can see that there will be a return, but pineapple will be cut off because pineapple obviously require many more of this character set. So it is not really realistic to use regular expression in this way. Now this is where quantifiers becomes useful because quantifiers simply are used to specify the number of occurrences in that pattern for a match to happen. So long as there's a single match of that pattern, the remaining characters of the same pattern will be matched too. So using quantifiers will reduce the rigidity of specifying the number of character sets to use. Okay, so we will cover 3 quantifiers. We will cover a quantifier using a dot symbol and a @ symbol and an asterisk symbol. And so we will see the difference between these 3 quantifiers. First, let's look at the @ quantifier. Now, an @ symbol in regular expression is a quantifier that matches one or more occurrences of a pattern in a string. Now, it is used together with another regular expression like a character set. For example, an @ quantifier can be used together with the character set of uppercase A to Z in line 28 by simply using the @ symbol after the character set. Alright, now a regular expression like this of a character set in uppercase A to Z followed by an @ will match one or more uppercase characters in a string. So in the example of matching the fruit names like pineapple, apple and orange in the target string variable, the findAll function in line 28 will return matches of uppercase characters that has one or more occurrences when the @ quantifier is used. So let's execute the code. So notice that 4 T's are returned as a result because the T is matched as there is one occurrence of an uppercase in the first word of each line. Alright. Now the name of the fruits are also returned because there are more than one occurrences of uppercase characters in the name of the in the fruit names. Alright. Now @ is a greedy quantifier as it matches as many occurrences of a pattern in a string. That is why all the other uppercase characters in the fruits are returned together as a word. So essentially, a greedy quantifier keeps matching uppercase pattern from the previous character to the next. For example, let's take a look at the first pineapple. Now, when the uppercase P in the first P of the pineapple is matched by one occurrence of an uppercase, a greedy quantifier will match the next character from the previous one and keep matching previous one to the next one until the match runs out. So the match runs out after E, since after E it is a white space. Alright, so this is how a greedy quantifier works. Now, in this way, using regular expressions like a to Z character set followed by a @ quantifier allow us to search for pattern without being too rigid, like how we specify a uppercase character of an exact fruit name to search for pineapple, and just searching for pineapple wouldn't allow us to extract the name of the fruits, regardless whether it is pineapple, apple, or orange. All right, so we want to specify a specific format instead of the exact word. On the other hand, using a character set of A to Z and specifying the number of character set of A to Z to search for a words in uppercase in sequence, it's also not helpful, as we couldn't determine the length or how many characters are there in the name of the fruits in advance. Okay, so I hope this is helpful and you understand how a add quantifier works. Next, we will look at the asterisk quantifier. An asterisk quantifier is similar to an add quantifier in many ways. It is used together with another regular expression like a character set, and at the same time, it is also a greedy quantifier like the add quantifier. The only difference is that the asterisk will match with 0 or more occurrences of the pattern, unlike the add quantifier that match with 1 or more occurrences. So using the regular expression of a asterisk quantifier after the character set of uppercase A to Z in line 28 will match 0 or more uppercase characters in a string. So in the example of matching fruit names from the target string variable, so matching the pineapple, apple, and orange, the findAll function will return matches of uppercase characters that has 0 or more occurrences when the asterisk quantifier is being used. All right. Now, since it quantifies by 0 or more occurrences, it will also match non-uppercase characters in the target string variables as well, and that includes the lowercase as well as any symbols like full stop and white space as well. Okay, and the findAll function will simply return them as empty values. So notice that the findAll function in the last documentation, the last sentence of the documentation says that findAll will return matches, empty matches are included in the result. Okay, so let's execute the code to understand this better. So as we execute the code, notice that the returned output from the findAll function will also return the 40s, just like the add quantifiers, right? It also returns the name of the fruits as well. So the pineapples and apple as well as orange are returned as a result too. But since it quantifies by 0 or more occurrences, the other non-match characters are returned as empty values. So notice that there are many empty values. Now these empty values are matched by the non-uppercase characters in the string. So let's take a look at the example. Let's see that, notice that there are 14 empty values between the first uppercase T and the pineapple. These 14 empty values being returned are matched by the 14 characters after the first T on the first line. So from lowercase h onwards, all the way to the first uppercase P in pineapple, there are 14 characters including white space. So these 14 non-uppercase characters are returned as empty values from the findAll function. Okay, so this is the difference between the add and the asterisk quantifier. So I hope this is helpful. In the next video, I will explain what is a dot in regular expression. Dot in regular expression is not a quantifier per se because it can be used without any other regular expression pattern, which is unlike the add and asterisk quantifier that are always used with other regular expression patterns like a character set. A dot simply returns any character in the string, and that includes uppercase character, lowercase characters, white space, symbols. The only thing it doesn't match would be a new line, which is denoted by a \n. Okay, so to understand how dot works in regular expression, let's supply a dot in the pattern parameter in line 28 and remove the character set and simply just use a dot. And let's execute the code to see what is the return output. Now, since a dot return any character, the findAll function will return all the characters individually from the target string variable. And it returns uppercase character, lowercase character, white spaced, and even the full stop in each line is returned as well. Now, if you use a asterisk quantifier or an add quantifier by itself, Python will throw you an error because the quantifiers has to be used with other patterns. Okay, so if you look at the error that is returned, it will say that nothing to repeat at position 0. That means that it needs a pattern before using the quantifier. So that is the difference between a dot and the quantifier. Now, although it can be used by itself, dot is normally used with other pattern like a character set as well. So let's perhaps include a character set of uppercase A to Z followed by a dot and see what is the return output. Now, this pattern will match two characters in sequence. The first character has to be an uppercase and the second character can be any character. So when we execute the code, we can expect that the findAll will return any characters that matches an uppercase followed by any character after that. So we can see that TH from the first two characters in each line is returned as a result. All right. Uppercase PI from pineapple is also returned because it also fulfills this pattern criteria. All right. So you may wonder what is the purpose of a dot since it returns any character in regular expression. Now, dot is commonly used with other quantifiers. For example, we can use a dot followed by a add quantifier. Okay, and if you execute the code, notice that a dot and a add quantifier will return the 4 lines in the target string variable as 4 items. All right, so you can see that price of a pineapple ice cream is $20, full stop, followed by a white space before the closing quotation, right? And then the next line is also returned the same, followed by the third line, also the same, followed by the last line. Okay. Now, if I include the specific uppercase word like a pineapple right before the dot and the add quantifier and execute the code, it will return something quite similar as well. So you can see that the first two sentences, right, starting from pineapple ice cream is $20 from the first line, is returned in from findAll function, followed by pineapple is $10. All right, in the second line is also written, and notice that there is also a white space before the closing quotation. Okay, now as a little exercise, I will leave you to think about what does dot and an add matches. All right, and why does the pattern return the whole string instead? Okay, so it will help you to solve the coding. Now, if you understand this, it will help you to solve the coding in the individual assignment that requires regular expression. All right, so see you in the next video. Now that you have learned about character sets and quantifiers, I would like you to write 2 regular expressions. The first one should match only the name of the fruits in the target string variable. So it should match pineapple, apple, and orange. And the second regular expression should only match the digits. In this case, 20, 10, 5, and 4. So if you like to solve this, you can pause the video and try it out. Let's write a regular expression to match the digits first. Now, to match a digit, we can use 0 to 9 in the character set in line 28. So we simply replace A to Z with 0 to 9 in the pattern parameter and execute the code. Now, notice that a single character set would only return to us each digit as single character. So 20 from the string is actually returned to us as 2 separate characters as well as 10. So this didn't really do the job. Now what we can do is we can include a add quantifier so that the add quantifier can match one or more occurrence of the digit. And since the add quantifier is a greedy quantifier, it will return to us as many digits as possible. And let's execute the code. So you can see that using a add quantifier this way would solve, or rather would match the number of digits regardless of how many it contains in the target string variable. Next, let's write a regular expression to match the name of the fruits. Since the name of the fruits are in uppercase characters, we can use the uppercase A to Z in the character set. So in line 28, we will revert to A to Z. But since a single character set will match the uppercase character as a individual character, using the add quantifier will help us to return as many characters as uppercase character as possible, since add quantifier is a greedy quantifier. So when we execute the code, we will be able to return to match all the name of the fruits regardless of the number of characters it contains. But at the same time, the add quantifier quantifies for one or more occurrences, so the uppercase T at the beginning of each line is written as a result as well, because of the quantifying of one or more occurrences. So to match only the name, we can include another uppercase of A to Z character set after the add quantifier. Okay, so let's execute the code. And you will see that only the name of the fruits will be returned, or will be matched and returned this time. Now, let's try to understand this a little bit. Now, while the first set of character set with uppercase A to Z followed by the add quantifier, while it will match one or more occurrences in the uppercase character, adding another character set of uppercase A to Z will mean that the match will require a pattern of another uppercase character after the first occurrence. Therefore, T will not be matched. Okay. Now, can you think of another regular expression that can also produce the same result?